Okay, so number one, I got negative 3/20. Number two, I got, hopefully I didn't make any silly arithmetic errors. Am I good? You guys all good? Good with number two?
Yes. How'd you get 15?
How did I get 15? So let's see here. Let's trace it through. I did 6 times 4 and got 24. And then, did you not distribute the negative?
Yeah.
Okay. So you had 33 instead of 15. Okay, yeah. Yes, Mason.
How did you get plus 15? I got plus 33.
Did you have plus 33?
Yeah.
Okay, so when we do this initial distributed property, I'm assuming you distributed the 6, right?
Yeah.
So we also want to distribute this minus sign because we're not just subtracting the first term in that expression, we're subtracting the second term as well. So minus 4x squared is just minus 4x squared, and minus positive 9 is really just minus 9. And so then, of course, when you combine the 24 and the negative 9, that's when you get 15. Make sense? All right. What else can I do? We'll get to number 4 in a second. Yes, ma'am.
On the first one,
Yeah.
how'd you get 12 and 20? Isn't it 2 over 5?
Isn't it? Well, let's go back here. So I multiplied, I cross-canceled and got 3/5.
Oh, I got it.
Okay. So then, and let me just make sure I tied all this up. Then I multiplied this one top and bottom by 4 to get to 20ths, and there's my 12. Because I guess we could have done it as 6/10, right? And then then you multiply the top and bottom by 2.
Yeah.
Is that what you were referring to?
Yeah.
So that would work fine as well. Yeah. All right. Keep your questions coming if you've got them. Okay, well then let's take a brief look at number 4. Remember, my goal for you today for number 4 was just that you would read it as a story and see if you could draw a picture. So let me give you an example of what a picture might have looked like. And I don't know what level of detail you got to, but it says that Abby leaves her house in Highlands Ranch for the mountains. Her sister Candace leaves, assuming the same house, at 7 p.m. They're driving at various rates. The mountain house is off in the distance somewhere. Will Candace catch up to her sister? Show your work, blah, blah, blah. We just want to draw a picture. So did you draw anything like this? Like I kind of think of a starting line that would represent Highlands Ranch. And these guys take off, but they take off at different times, don't they? So I would say that Abby left early. So would it be fair to say that Abby kind of got a head start? So maybe this is Abby. Abby jumps out to a head start. She takes off for the mountain house. And Candace didn't get the head start. She also takes off for the mountain house. And wouldn't this dotted line out here that I'm drawing, wouldn't this represent the place that Candace would catch up to Abby? So I don't know. Did you have any drawing like that where there was like somebody like indicating somebody's getting a head start? Does that make sense? Somebody's getting a head start here, and then the person who didn't get the head start might catch up to them. Why on earth would Candace even have a chance to catch up to Abby?
She's going 20 miles faster.
She's going faster. Is it 20 miles an hour?
Yes.
30.
Oh.
40 and 70, right?
Mine says 60. Yeah.
Oh, really? Yours says something different than mine?
Yeah.
That's weird. Okay. In the future, I might have you guys change to my numbers. There might have been some editing. But regardless, she's going faster, right? Regardless. Did anybody try to go past this? Let me do this. As far as a picture, would you be okay if I wrote this as distance of Candace, like DC for Candace's distance? Does that make sense? If I was going to do that, what would the black arrow be labeled as? Yeah, Abby's distance, D sub A. Yeah. Just for sake of argument, since you have it in front of you, let's use your numbers today. don't know why I don't know. That's weird. So you said that Candace did 60 miles an hour?
Yes.
Okay, so I'll change this over to 60 just so we can agree. So Abby left early. How many extra hours did Abby get driving? 1 extra hour. So could anybody say what her mileage head start was? Like how many miles was Abby down the road before Candace even started?
60. Oh.
40.
So Abby got a 1 hour head start, didn't she?
Yes,
And how fast did she drive in that 1 hour? 40 miles an hour. So in 1 hour, she went 40 miles an hour. So what's her head start? It's 40. It is. If you're going 40 miles in an hour and you travel for 1 hour, aren't you 40 miles down the road?
Yes.
Okay. So then we could say that this little gap here, this head start, is actually 40 miles. 40 miles. Okay, so we're not going to take this one all the way through to the finish line, so to speak, but I do want to see if you guys can do this. This next step is a really crucial step, I think. Looking at this picture, you've got a couple things going on. You've got the distance that Candace went, represented by that long red arrow. Got the distance that Abby went, represented by the shorter black arrow. And then you've got the 40-mile head start that Abby got. We've got to relate all this stuff, right? We've got to write an equation that puts it all together. Does anybody see anything? There's a number of ways you could do this. There's not just any one way. But can you write a relationship down in which all those things are used, and it's true? Let me do the same thing I did yesterday. Can I write a false statement? What if I wrote this? And can't you tell just from the picture that's false?
Yeah.
Clearly the red arrow, based on the situation, is longer than the black one, right? So that would be completely false in this situation. Other times that'll be true, but in this case, it's false. What do you think, Ray?
110 miles equals D1 plus D2.
110 miles equals D1? I'm using DCs and DAs.
Okay, sorry. DA plus DC.
DA plus DC. Where are you getting 110? Is that? Oh my gosh, it's different?
Number of miles.
Okay, I didn't realize that was different. Let me fix that. Sorry, that's really weird. Okay, so 110. Now we're talking about the same numbers. Okay, so now Bray's idea is using all the numbers and such that you have there. Do you guys think that that's true?
No.
What does the 110 represent?
The total.
Miles from where to where?
Their house to their other house.
Their house to the mountain house. Do we know that they even get to the mountain house before the catch happens?
No.
I mean, the mountain house could be in a number of places, right? Couldn't the mountain house be out here somewhere? Couldn't she catch her before they got to the mountain house? Or could it be that the mountain house is actually here and Abby just beats Candace to the mountain house? That's possible as well. So the 110 in the end would be important, but I don't think that we need it in there yet. But I must say that Bray's idea is not without merit. He's trying to put these things together in an equation. So even though the orange equation is not the right equation, he's thinking about the right kinds of things, right? Keep thinking. What else can you, using all the stuff we have up there on our picture, what else could we write that's true? The value is really in you coming up with this. I could write it up there and we could all be done with this in about 5.2 seconds. So I want you to try, and I want you to succeed or fail, and at this point I don't really care. You shouldn't either. Just try. Bray, you had another idea?
Yeah.
Go for it.
6 p.m. plus 7 p.m.
It should be distances, right? So when I say, maybe I'm not being terribly clear. What I want you guys to try to do is take everything in this orange box and nothing else. Only the stuff in the orange box, and try to write an equation using all the stuff in the orange box that's true. That makes sense? So 6 p.m. and 7 p.m. are important, right? We use those already. But I want you to use that stuff. What do you think, Sophia?
Did you write DC equals 40 plus DA?
DC equals 40 plus DA. Now let's analyze this. She's clearly related everything, but let's analyze this for truth. You think this is true? Looking at the picture, reading the little bit of information we got up there, is this a true or a false statement? Trevor's giving you the head bob. So you're saying yes, you think it's true. Okay, I'm going to see. Oh, I got the head bob from Sydney. There's 2 whole people that are like, maybe I think Sophia's right. Anybody pretty sure that Sophia is incorrect? Bree, what do you think?
Well, not like 100% sure, but 40 miles per hour, that'd be multiplying, not dividing, not adding.
That's not 40.
Oh, 40 on the box, okay.
Yeah, everything in the orange box.
I don't know.
So you've gone back to the I'm not sure category.
Yeah,
Okay.
I was thinking of something else.
Okay. What's hard about that is 40 miles per hour is a rate. And if traveled for 1 hour, then they went 40 miles, right? So the 40 kind of shows up twice, yeah. 40 plus DA equals 110. What do you guys think about that? Is that true or false? What does the equals 110 tell you?
Like that's the mag. That's where they end up.
That means they got to the mountain house, right? Chase is right. So if we say the Head Start, why don't you clap for me when I say right things? Seriously. Weak, Mason. You should clap for me when I say right things. Anyways. When I say 40 plus Abby's distance equals 110, doesn't that mean that Abby definitely got to the mountain house? Do we know that?
No.
We don't. We think that maybe Candace might have caught up to her. We're not for sure, so I don't think we can really use the 110 here because we don't know. Did the catch happen before the mountain house? Did the catch even happen, did Abby just beat Candace to the mountain house? So I don't think we can really use the 110 in that way. What if I labeled it like this? Let's see if this helps you clarify whether this is right or not. Oops. Just look at what I'm writing. Long distance is equal to head start plus short distance. And guys, listen, I know in math classes, so often, it feels like it's all about my teacher taught me a way to do this, and so I just basically copy what my teacher did. You know what I'm talking about? The question I'm asking you is this. In your brain, is that logical? I'm not asking you for a procedure. I'm not asking you for a right answer. I'm just asking you, does that make sense?
Yeah.
Does that make sense? It's a weird question, right? In a math class, isn't it usually what's the right answer, Oliver? Sophia, what's the first step? Sydney, what's the second step? Right? You know what I mean? I'm just asking you, does this make sense? I hope it does, because this is right on the money. It's a perfect relationship. It's great. Who said this? I forgot. Sophia. Yeah. That's great. Longer distance is equal to the short distance plus whatever the head start was. This is an exact right relationship. I don't know. There's another way you could have done this. Did anybody think of this? DC minus the head start equals DA? Isn't that the exact same equation, just rearranged? All I did was subtract the 40 over. But somebody might have said, hey, the distance that Candace has to go to catch up, minus 40 minus the head start would equal the distance that Abby went. You could have looked at it that way as well. Or you could even done this. How about this? DC minus DA equals the head start. The final answer on this one? No, but I can figure it out for you. So let's see here. Let me erase this stuff. So don't feel compelled to just copy this down because we'll do at least one example here of this here in a second. So distance of Candace, that would be 40t. No, Candace is going 60. So it'd be 60t equals 40 plus 40t. So this would be 20t equals 40. So time, it would take her 2 hours to catch. It would take her 2 hours to catch up. So then if we think about this, in 2 hours, wouldn't have Candace got, so I'll just write it up here. In 2 hours, Candace would travel how far? How fast is Candace going? Yeah. Candace is going 60, right? And so times 2 hours, so she'd need to travel 120 miles to catch up to her. But how close is the mountain house? So she's not going to quite catch her, is she? Because she'd need 120 to catch up to her, but she only has 110 miles of road. So the answer here is no catch. She will not catch her before the mountain house. So anyway. Okay, how are we doing? Okay, so as I mentioned before, in our current unit here, we're going to be working today again on this, and we'll continue for the next weeks to continue to process this. So again, if you look at what we do today and you think, oh my gosh, Mr. Anderson, I don't have this completely mastered yet, calm down. It's okay. We're going to work on this a lot. If you're making no progress at all, well, that would be cause for concern, right? But if you're making like little progress and a little step here and maybe a step back, but then 2 steps forward or something, that'd be great, right? Hopefully in a week or two, you'll be doing pretty good. So I would like to do a little jumping around here. Yes, I'm going to go here. We might actually go back in time a little bit as well. Let's do practice 1. Oh, and by the way, reminder that tomorrow we start our big project for Unit 3. I'm so looking forward to it. It is designed to be completely done in class, right? So if you're doing what you're supposed to be doing and you're here in class, the intent is that you would not be doing really much of anything with this project at home. You'd just be doing your homework assignments, keeping up with that stuff, but the project will be in class. In order to be successful, you're going to need to have some kind of a device that you can do research on, like a computer or a phone or something, and to be able to make the progress you're going to need that.
We're going to be doing this project
More or less, yes. So this week, the rest of this week, project, all of next week, project. When you come back from Thanksgiving, we'll have a review day and then our final unit test. The project will be due somewhere in that last week as well, and then more or less, that's the semester. So, yeah.
When do we find out our groups?
Tomorrow.
Oh, I thought it was in a group of 4.
No, we'll probably do groups of mostly 2s. I think I can get away with 2s in here. I like 2. 2s is a good number because that pretty much makes sure that everybody's doing something. Once you get into groups of 3 and 4, don't you always get that one person who's like, get to work, can't wait to see what you guys do, right? The group of 2, it's kind of like, well, it's you and me. We better get started.
When are we going to know what it is?
When are we going to get to what?
Know what it is.
The groups?
The project.
I'll hand it out to you tomorrow.
No?
Yep, I've got it all printed out, ready to go.
Yeah.
Okay, so take a minute here with practice 1, number 1. I want to take whatever time we need, so let's dig deep. So when I ask you to think, don't just let your mind go into neutral and say, gee, I wonder about ... and think about something else entirely. Really think about this. This is how you're going to make progress, and you can discuss and all that stuff. So the first thing I want you to do is read this. I'll read it out loud. Read it with me. The first thing you're going to need to do is try to draw a picture of this story. So here we go. 2 remotely controlled unmanned aircraft are launched in opposite directions as shown in the awesome picture above. One flies east, and the other one flies west. Clearly at different rates. How long will it take the aircraft to be 560 miles apart. So your first job is not to answer the question. Your first job is not to do stuff with a bunch of numbers. Your first job is simply to draw a picture of what's happening. Like a GPS, like a satellite would be looking down and seeing what these distances are doing, the distances of these planes. That's your first job. Just draw a picture. They start in the same place though, right?
Oh, yeah, are we assuming that it's in the same place?
Yeah, they start in the same place.
Okay.
If they didn't, we'd need a little more information.
Yeah.
Which we could still do that, but I think based on the information we have. Oh, was that a compass? Got it. Wasn't sure what that was. Okay. I know we're still pretty new at this, but is there a brave soul that would like to draw a picture of what's going on? All right, here we go. So would you use different colors for the two different planes? Right now you're on orange,
Okay.
and you can just tap on that and change to a different color if you, when you get to the second one. So let's see what he came up with. So compare this, compare what you're seeing. Could you make one of the arrows a different color, just so we could call
Oh.
it like the orange plane and the...
Yeah, how do I do that?
Just tap on the pen that's highlighted, the orange pen that's highlighted, and then you
Oh.
can, change to a different color.
Perfect. How do I erase?
You can switch to the eraser tool right there.
Okay.
He's got an orange arrow going to the right. He's got a purple arrow going to the left.
And then,
Okay, so what do y'all think about that as far as a picture? Is that what you wrote? They start here, they go in opposite directions. Nice work. Nice work. So are you going to have more to write?
yeah.
Okay, so he's going to write some other stuff. Let's see what he writes. I don't know. Hopefully it's good. Okay, so the east plane. Okay, so he's put more information. East 78 miles per hour. Got a west plane going 82 miles per hour.
And then,
He's giving us a lot of information. This is more than a good picture. Okay, so reactions. So all that stuff. Again, and my question to you is simply, does this make sense? Is this logical?
Yes.
Sebastian's with Bray. This is logical. Okay.
I'm done.
Just like the picture?
Yeah.
Okay. So, Brayden, have you write a little bit, just a little bit more.
okay.
I like your picture as well, and you've gotten a lot of information up there. I do have one question for you. I get that the east plane is going 78, and the west is going 82. I'm wondering about the 560. Like when writing the 560 over here on the right, 560 on the left. What are you indicating by that?
It's kind of like once they're reaching that spot where they're at 560 miles away
Away from what?
from each other.
From each other. Okay. So on your little purple-orange drawing there, can you represent what that 560 would look like? Like how would the 560, like you just kind of drew, I feel like you wrote it out there as like, hey, this is an important distance, right? What would that look like on the picture though? Maybe use the blue pen just to be consistent.
Okay.
Think about what that would look like.
Would it be like the two planes far away from each other?
You mentioned they would be 560 miles from each other. 560 miles apart. Okay.
Maybe?
Okay. So it looks like he's trying to, you correct me if I'm wrong, and maybe you guys can straighten me out on this. It looks like he tried to line up the purple arrow with one of the blue dots and the end of the orange arrow with the other blue dot. Was that your intent? Does that make sense to you guys? It'd be 560 miles apart. This is a pretty good drawing. I think this is really quite a good drawing as far as what's happening. We haven't really, and he did list a lot of numbers in there. We haven't really gotten into the math of this yet, but I think we have a really good start because we have a good drawing. Okay. Was that painful to draw?
No.
Was it scary?
I mean, I just not good at drawing and writing.
Oh, who cares about that, right? Neither am I. Thank you. I asked that question only because the rest of you can do the same thing. So I'd encourage you to do that. I'm going to pick up your 560 miles thing and move it.
Okay.
If I can, hopefully. There we go. Okay. I just want to move a little bit closer. Anya.
So I have a question. So like, if the distance between them, wouldn't that be just like 160 first? Because you don't know how much time it would be until they're 560 miles apart. So right now the distance between them is only 160 miles.
Well, so, okay. This is where there's some potential confusion. So the eastern plane is going 78 miles per hour, and the west is going 82. So I'm assuming you came up with 160 by going 82 plus 78.
Yeah, and then like x, because you don't know like how much. I just said 160 x like equals 500.
Yeah, so you're adding their rates, right?
Yeah.
I don't think we need to do that because we know, I mean, think about it. You said right now, and by right now, do you mean at the start?
Yeah. So
You know, where, let's go there. Where are the planes at the start? The 0, okay, because at what location are the two planes? At the start. Aren't they at the same place?
Yeah.
So if they start right here, then at the start, they're 0 apart,
Okay.
right?
Yeah.
So when you say right now, let me form this as a question. At what time would they be 160 miles apart? After 1 hour. Who cares about 1 hour? Why did you pick 1? Why not 2? Why not 5? Why not 10? You know what I mean?
Yeah.
So I don't think we can say that, hey, 1 hour is really important to us. It might be, but we don't know yet.
Yeah.
At the beginning, at the start, they are 0 miles apart. It's true, an hour later they're 160, but we want to know at what time they're 560 miles apart. So this is where people get into trouble, because you know what they do? They'll go, after 1 hour, 160. Right? After 2 hours, 320. After 3 hours,
240? No.
480. And they say after 4 hours, 540. Oh, there's like this 20 mile an hour thing left over. And they try to do this. They try to go this bing, 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 bing. And they end up with this little fractiony thing that they don't know what to do with. And that's why the process that I'm trying to get you guys to buy into is best. Because you don't end up with this awkward fraction thing of like 160, 320, 480, 540. We're almost there. Oh, went over. What happened in between, right? I hope the hand motions make sense. Would anybody think of that? 160, 320, 480. It didn't work, right? So, yeah. So Brace started us off really, really good. I'm going to add just one little thing to both of them. I'm going to call this purple distance. I'm going to call this distance of the plane that went west. And the orange one I'm going to call distance of the eastern plane. Because on my little map here, I only want distances. I mean, the fact that he labeled some rates up there is potentially useful. We'll use those in a little bit. But I want to have all distances. So here's what I want you to do. Here's where we get to try to be logical. Everything that I highlight in gray, I'm highlighting certain things in gray. I want you to try to write a relationship, aka an equation, that uses all the stuff that I highlighted in gray. And the only other requirement is that what you write must be true. That's it. It's got to use the stuff in gray, and it's got to be true. Anybody have a suggestion? Mason, what do you think?
DW plus DE equals 560.
DW plus DE equals 560. Okay, so Mason, thank you. This is where we get a chance to look at it and say, basically, does this seem logical? Does this make sense? So think about it. He said the distance of the western plane plus the distance of the eastern plane will equal 560. Does this seem to make sense to you? So let's get a quick show of hands. Raise your hand if you are thinking, yes, this does make sense. Okay. Raise your hand now if you look at it and say, that makes no sense. I think it's something else entirely. So Mason, everybody so far is either neutral or on your side. It's a good place to be. It's a good place to be. Did anybody think of something different? Because there was like 3 of you that maybe threw your hand up real quick. Did you guys think of the same thing? Sydney, I think, did you have your hand up at one point? Did you think of the same thing? And Sophia? Hey, Mason. Beautiful. It's totally logical. If you take the western segment plus the eastern segment, wouldn't you get the whole thing, the whole distance? Yes. So awesome. Okay, so I'm going to take this. Actually, I'm going to pick this up and move it as well. I'm just going to put it over here to give myself a little bit more room. And here's how we actually are going to bring the math into it. The main relationship here between all this that connects it all is that distance equals what times what? Do you guys remember this from yesterday?
Speed.
Rate times time or speed times time. Yep, same thing. Okay, so now we get to pick the question apart a little bit. The west plane. What is the speed of the western plane? 82. That's right. So we're going to say that dW is really 82 times time. I'll write that with 82t. Plus, what's the speed of the eastern plane? 78. So I'll put that in there as 78 times time. 78t. I think it's important that you actually write this down. Writing down, taking your pencil and putting pencil to paper actually has significance for you learning and remembering. And this, of course, equals 560. Okay, does this look like an equation we could solve?
Yes.
I sure hope so. Don't we have 2 like terms on the left?
Yes.
So it'd be 160t. There's Anya's 160 for every hour. They get 160 miles further apart. Equals 560. And then how is it that we would actually solve for this time? Division, yep. So we divide both sides by 160. So this would be where the calculator would come in handy. 560, say again? 3.5 hours. Okay. So 3.5 hours is the time that it would take for these 2 planes to get that far apart. Okay. So it all started with Bray drawing a good picture. And then we took the stuff off his picture, and we had a good relationship from Mason. And then I reminded you that distance equals rate times time. Kind of finished from there using some good equation solving techniques. Okay, so remember what I said yesterday, what I said about 10 minutes ago. It's possible that this could take you a week or 2 to fully master. The idea would be that as each day goes by, you get a couple degrees better than you were yesterday. And I hope as you reflect for a second, hope you can look at this and say, well, yesterday I felt like a complete and total beginner, and now I feel a little bit less like a total beginner. I can see it a little bit better. I'm not expecting you to have be like a total master yet. If you are, that's awesome. It's great. But if you're not, that's okay. So we have about 5 minutes, and I would at least like to try to set one of these up, because I think the setup is sometimes a really useful thing. I want to actually, with this we're going to go back a little bit. Yes. Let's go back a day. Let's go to the rock climber question. Rock climbers traveling the Southwest by car and minivan. So I'll read it out loud. Your one goal, your one and only goal right now is to listen to and read this. Just think about what the story is and then we'll try to draw a picture of this, and maybe we'll get the relationship down, and if not, that's okay. We'll just get as much done as we can. So it says a group of rock climbers is traveling the southwest by car. Their gear is carried in a minivan. How long will it take the car, traveling at 60 miles per hour, to overtake the minivan, traveling at 50 miles per hour, if the minivan had a half-hour head start to the next climbing location? Interesting. How long will it take the car to overtake? Isn't overtake a synonym for catch in this situation? So what I want you to do is just try to take a second and sketch a really rough map, like a satellite level map of what these distances could look like. And kind of like what we did before, I'll take hopefully have a volunteer that would like to share their picture. And I'll even put it on the purple color. No, I'll put it on the blue color for the van. So once you think you have a picture, Ray wants to take another swing at this one. I'll give you all a chance to process. You should give it a shot. I got it on blue for van.
Okay.
But whatever, you can switch to purple for the car. So Bray's going to try to show us again. Any of you can do this. It's okay. I have no idea what Bray's going to do. He might completely fall flat on his face. And we need to be okay with that. We're just practicing. Everybody can win. Everybody can try. Assuming the red line is supposed to be as straight as possible, right?
Yes, yes.
There's mountains there, but
Mountain.
yes, sir.
You know what?
3 times 50 is 150. We're pretty sure it's 3? Pretty sure?
Would this be in miles or minutes? What do you think?
I think everything on the picture really in the end should be about distance. So the
Okay.
fact that you've got a mileage on there,
This is good?
I think it's real good.
Okay.
Yeah. Okay, so we do need to wrap it up here pretty soon. I think Bray is really close. I think there's one little thing we probably want to fix here. He wrote 30. What did the 30 stand for?
30 minutes.
30 minutes. Okay, so I don't know that we need to fix this. We probably just need to clarify it. I think it's most useful if everything on your picture is distances. So I like your blue arrow. I like your red arrow. I think those make a lot of sense. But I think I would just do a little bit of different labeling. I think I would call this right here distance of van.
Okay.
And I would call this distance of car.
Yeah.
So you're visualizing this really, really well. I would just have you label it a little differently. And then what about the 30? If the 30 was going to be a distance city, what do you think?
I don't think that's true because like it was traveling at 50 miles per hour, so wouldn't you like 15?
Say 50 and a half?
Yeah, because it's like if they're going 50 miles an hour.
For how long? How long was their head start? Half hour, 30 minutes. So, Julia, what was the actual distance they went? Sorry, Chase, did you just say it?
Yeah.
What is it?
25 miles.
The difference is she had her hand up and you were just shouting out, and you were talking over me and I didn't hear you very well. 25 is it, isn't it? So I would say, instead of writing 30 there, I would write 25. Let me leave you with this. Isn't this the exact same thing as Abby and Candace?
Yes.
This is somebody trying to catch up to someone else. Okay? So we'll probably revisit this one at some point. Come ready tomorrow for the project. Hope you all have a great day.
2 hours, 2.5 hours.
I don't know. Let's find out real quick. I'll finish this one real quick if you want. So, thank you. Appreciate you volunteering. So it would be here is equal to DC, so it would be 25. Distance of van would be 50t. Distance of car would be 60t. So 25 equals 10. So hey, Mason, it's actually 2.5 hours. 2.5. I did the work off to the right there. You had just drawn that answer out there. I think it should be 2.5.